So today we have our daily question, which is Leetcode 1514 path with maximum probability. So we are given an undirected graph of n node. It is zero based indexing represented by an edge list where edge I is equals to a and b is an undirected edge connected the node a to b and the probability of success of traversing that edge. Given to node start and end, find the path with the maximum probability of success to go from start to end and return to its success probability. If there is no path from starting to end, return 0. Your answer will be accepted if they differ from correct answer at most 1 to the power 5, which minus 5, which means that there would be some error in rounding of the double value, so it's being ignored. And we are given one example. Let me just quickly take you to the notepad. We will use our Dijkstra's algorithm. We will use a modified Dijkstra's algorithm. So suppose we are given this kind of graph 0 1 and 2, and the probability of going from 0 to 1 is 0.5 and 0.2 and 0.5. The input in the question is given in the form of edges, but we will transfer it in the form of adjacency list to make our traversal easy. We will do it later on, but let's first understand what is the logic behind it. So we will take an array visited which will hold the value of double and the probability of reaching that value, and we will also take one max heap this is our max heap, and it will contain probability as first element, pair of two elements. First one will be the probability and the second will be node, and initially this visit will be all 0. And we will keep on taking our nodes, and nodes will have we will have our current, and current will have our node as well as our current probability. Okay, so the initials, we have one initial thought which we should consider is, suppose we have this as our start node, then the probability from going from start node to its own will be 1. We are standing at 0 and we want to go to 0. We have probability of 1. Okay, so here we start our question. We will make this start node of visit as 1, and we will push this 0 and 1 inside our priority queue max heap. So now our iteration will start. We will pull out this element from max heap, node will be 0 and current probability will be 1. We have two adjacents of 0. We have 0 and its two adjacents are 1 and 2. 1 and 2. So we will multiply our current probability and the probability of going from 0 to 1, 0 to 1, which is 0.5, which will be equals to 0.5. Now we will check that is my new probability is smaller than the visited one of the child node. So we have our child node as 1. So we will check over here. So 0.5 is greater than 0. So we will push it, we will amend it 0.5. We'll have updated it over here, and we will push this new probability of 0.5 and the child node, which is 1, in the max heap. So this portion is complete. Now we have our adjacent 2. So we have 0 and we want to go its adjacent 2. 0 and its adjacent 2. So what we will do is multiply our current probability with our previous probability, which is 0.2, and which will equal to 0.2, and we will check if our child node, which is 2's probability, which one is greater. So our new probability is greater than the previous one, so we will just amend it and push it into the max heap. So this portion is completed by us. So now what we will do is we will take the top element from the max heap, and whatever value is greater will be pulled out. So our current probability is 0.5, which is max, and the node 1 will come out. So we will see that our 1 have two adjacent node, 0 and 2. So we have 1 with our adjacent 0 and 2. Its current probability is 0.5, which will be multiplied with our already existing probability, which will be 0.5 over here, which will be equals to 0.25. Is this new probability for the child is greater than the visited one? The answer is no. The one is already greater, so we will do nothing for it. So now we will check for the second adjacent of 1, which is 2, and the current probability of going there will be 0.5, and we will check what will the probability of 1 to 2, again 0.5, which will again equals to 0.25. We will check for 2, this one. So this 0.25 is greater than 0.2, so we will replace it over here, 0.25, and we will push it into this 0.25 and the child node, which is 2, into this. So now what will happen is, the iteration is complete. We will now check again the top of the heap, which is 0.25. So our node 2, we have adjacent 0. We are checking right now, like we have 2 and 0, and its probability is 0.25. So we have our current probability 0.25, which is multiplied by 0.2, which will equals to 0.5, and we will check over here that this thing is not greater than 1. 0.5 is not greater than 1, so we will not replace it. So now we will check for the another adjacent, which is 1. So 0.25 multiplied by 0.5, which will be equal to 0.125. We will. So now this 0.125 for adjacent 1 is not greater, so we will not do anything of it. We will pull out this last one, 0.2 node 2. From node 2 we have 0, which will be 0.2, and we have 0.2 over here, so it will be 0.04, and again which is not greater than this, so we will not do anything for it. And similarly for the case of 1, we have 0.2 multiplied by 0.5, which will be 0.1, which is not greater than this 0.5, so again we will do nothing, and this whole portion will end, and our answer will be present over this visited array, and this end node will contain my answer. So now let me just quickly take you to the code. So this is how our question starts. So we are given an edge, we are given an n number of nodes, edges. Suppose we have an array like this, and 0 to 1, and then 1 to 2, and we have then 2 to 3. Or suppose the given example of ours, this was 0 to 1 node, 0 to 2 node, and 2 to 3 node. So this is how the input is given to us, and success probability is will something look like this. From 0 to 1 we have 0.5, 0 to 2 we have 0.2, and 2 to 3 we have 0.5. So this is how our input will look like. So what we will do is, now we will just convert this whole into adjacency list. So the adjacency list will look like 0, 1, 2, and it have its is adjacent as 1, and 0.5 is the probability, and we have another adjacent 2 with probability 0.2 from 1. And it is undirected graph, so similarly opposite will also happen. So this is how our adjacency list would look like. This whole portion is doing that only. And then we have our declaration of our visited array, and we make the start node as 1. Then we have our max heap, and then we push into the max heap our initial 1 and the start node, and this is from where the loop starts. We pop the node from the top. We have our current, we have our node, as well as current probability. So these are those two lines, and we pop from the queue, and then from that node, current node, suppose we have our node 0, so we will traverse its adjacent, and from that adjacent node we will have our child node and the probability of going into that child, and we will then multiply our probability of that going to that child and the current probability, and then we are comparing it to the probability present in the visited array, and if it is higher in the visited, if it is lesser and our new probability is higher than already calculated probability, then we will replace it with a new probability, and we will push the new probability and the child node into the queue, and at the last of this iteration we will return our visit and the end node. So this is how this question will look like.